All right, let's discuss homocysteine. It's a test we do on all of our annual physical panels. I think it's a pretty important test. Everybody ought to have it done at least once a year. If you've got issues with it, more often than that, to keep an eye on it. I'm going to go through and explain why we test it, what it is, why it matters, what the normal range is, and what we do about it when it's out of range. So you're going to kind of get an all-encompassing little primer on homocysteine right here. Whether you've gotten it from one of your other doctors or whether you have a test from me and you don't remember our discussion about it when we went over it, this will be a good way for you to either revisit that or look at what you've gotten from your other doctor and interpret it on your own. All right, so what is homocysteine? First of all, Homocysteine, homocysteine. It is what we call an intermediate product in a pathway that produces something called glutathione. Now, glutathione is a very important detoxifier and antioxidant for a lot of different cells in our body, but it's very important for the brain, the nervous system, the blood vessels, the liver. Those areas of the body probably benefit more from glutathione than anything else, but it's important all over the place. Remember, every cell in our body creates kind of a cellular or metabolic exhaust as it burns through calories and processes things. It's got trash to get rid of. Glutathione helps with that. And then all the other trash we get exposed to, from food we eat, water we drink, the air we breathe, the stuff we put on our skin, colognes, perfumes, makeups, lotions, all that kind of stuff, medications that we take, all of that creates a toxic burden inside of us, and glutathione is one of our main ways to kind of be able to bag up that trash and take it out, right? Think about cleaning out a house. You wouldn't want to go through the house and every time you find something to throw away, you got to walk all the way out to the street and put it in the trash can, and then all the way back in the house and find the next piece. You'd rather have a bag that you can fill up with all that stuff and just take it out once or twice, right? That would be more efficient. Think of glutathione like that trash bag. It just makes it much more efficient and workable to process all the trash and get rid of it in a manner that doesn't cause damage anywhere else. All right, so what do I mean when I say it's an intermediate product in this pathway that creates glutathione? So let's say we were going to make some pancakes. In the beginning of the process, or the first half of the process of making pancakes, we would be putting ingredients together and stirring them up, and we would end up with a bowl of pancake batter. That bowl of pancake batter is an intermediate product. That's not what we're going to eat. That then has to go on the grill and become pancakes. Pancakes are the final product. That's the glutathione. So this bowl of batter, after the first half, we have the intermediate product. After the second half, we have the end product, which is going to be either pancakes or glutathione. All right, so you're going to hear me refer to that kind of making pancake analogy probably a couple of times, just because sometimes it's an easier way to think about it. So glutathione is that bowl of pancake batter. It's halfway through the process. All right, there are three main things we know when you have too much homocysteine. Now, I guess I should go ahead and tell you what that is. Normal range for me is going to be below 8. Normal range for most labs is going to be anything below 14 or 15 in most cases. Now, it's going to vary a little bit from one lab to the next, but it's going to be roughly in that range. Why the difference? Right? Why am I holding you to a different standard than the lab? Good question. The lab's normal range is not a therapeutic target. It is not what's physiologically appropriate. It is what's expected in the average person who has a reason to have this test done. Most insurance companies don't pay for homocysteine test to be done as a screening tool, like an annual screening. We get to do it because we don't take insurance. So people pay cash for their tests and they can do whatever test they want. But in a regular doctor's office, they have to have a reason to do this test, which is going to be something cardiovascular, blood pressure, AFib, heart failure, something along those lines, atherosclerosis, something like that. Absent of that, they're probably not going to do the test. So when you take everybody that's had the test done through a particular region of lab in a given period of time, and you plot this bell curve of all these people, and you figure out what the normal or expected range is going to be, that is an expected range for people who had a reason to do the test. Right? So almost by definition, it's not for healthy people. But we know from research and physiology and all of that, we know kind of where it should be if everything's working properly, right? And so less than 8 is where it should be. Now, is there a little wiggle room, 8.5, 9? Yeah, I don't get too upset about that if everything else is in pretty good order. But you get much above that, and I really think it's important to deal with it. Now, there are people that set the standard lower and they say it has to be below 7. I think I heard one person reference it being below 6. That's fine. You're just going to be treating everybody because you just don't see that without doing something to get it that low. But it's fine. It's still a good place to be. All right, but for me, the limit is 8, so I want it below 8. Now, if your level gets above 8, let's say it's 11, okay? What do we know from that? There are 3 main things we know. Number 1, we know that you're not making enough glutathione. If you have half a bowl of pancake batter left, we know that all didn't become pancakes. You probably don't have enough pancakes because there's a bunch of it left in the bowl. It didn't finish the process. So number 1, we know you don't make enough glutathione. Number 2, we know that whatever happens in that second phase that turns the homocysteine into glutathione, you have an issue with that. Well, that phase requires B12, B6, and folate. Okay, so 3 B vitamins are involved in that second half. Those vitamins generally also have to be methylated. So I'm going to talk to you about what that process is. But if you don't have enough glutathione and your homocysteine level is too high, we know that you have an issue with that second half of the process. So B12, B6, and folate, there's going to be something wrong with your ability to use those. Either you don't have them or you can't methylate them. Now, lastly, we know that homocysteine, if it starts getting higher and higher in your bloodstream, it can damage the inside of the blood vessels. It can go around, think of it like an SOS pad, like a scrubby pad. It can scratch the inside of the arteries. Now, each time it does that, well, not each time, periodically, if it does it in the same spot, bad enough, you'll get damage to the artery, and then your body feels the need to stick a Band-Aid on that damage. Well, the Band-Aid is typically going to be some form of cholesterol. That's what your body uses to patch up damage in the arteries. That damage could come from high insulin, high blood pressure, high blood sugar. It could come from high homocysteine. It could come from spike proteins. It could come from all kinds of things. But in this case, we're talking about it coming from homocysteine levels being too high. So over time, it can lead to hardening of the arteries. It can lead to high blood pressure. It can lead to a CRP test number that's going up, meaning there's inflammation in the blood vessels. So those are the 3 things we know. We know you don't make enough glutathione. We know you have an issue with the B12, B6, and folate. And we know that you may be doing damage to the inside of the arteries. That's what we know if your homocysteine level is too high. Now, let's talk methylation for just a minute, those B vitamins. There's a process that we use all throughout our physiology. I'm talking about one specific version of it here, but it happens in lots of different ways throughout our body. And that process is called methylation. And that involves taking a methyl group, which chemically is a carbon and 3 hydrogens, so CH3. Taking that methyl group and adding it to or subtracting it from a particular enzyme or compound or protein or whatever. And what you're doing with that is you're flipping light switches on and off, you're unlocking and locking things, you're opening and closing cabinet doors, so to speak. That's how we use methylation in our body. It starts and stops processes, and it gains and locks down access to things. If you wanted to copy a chunk of your DNA in order to make a protein, you would use a methyl group to open that up, make it available, you make your copy, and then you remove the methyl group and it closes up again, right? It would be a process like that. Again, a little bit oversimplified, but you get the point. We use it all over the place. In this particular case, with B12, B6, and folate, the way you methylate is through a mechanism that's provided by a gene called the MTHFR gene. Doesn't stand for what you think. It stands for methyl tetrahydrofolate reductase. That's the gene, and that's the enzyme that this gene makes that allows you to methylate these B vitamins and get them useful so that you can convert homocysteine into glutathione. Now, many of you have heard of the MTHFR gene. There is a famous author, well-known author, I think probably sounds better to say it that way, named Gary Brecka, who does a lot of lecturing on the MTHFR gene mutations. And he estimates, well, I mean, science estimates, he talks about it, about 40% of the population has some sort of genetic mutation to that MTHFR gene, which could leave you somewhat deficient in your ability to methylate. Now, you can do genetic testing to find out if you've got the genetic mutation or what version of it you have. There are a couple of different ways you can mutate it, and then you can mutate one copy of the gene or both copies of the gene. So that gets a little complicated, but that would all determine how damaged your ability to methylate really is. Now, let's say you already knew you had that MTHFR mutation, and you wanted to know, is it bad enough that it's actually causing trouble in me? Because just because you have the mutation doesn't mean that it's a problem for you necessarily. Let's say a perfectly normal, healthy person is born with 100% of their ability to methylate. And because you have this mutation, you only have 70% of your ability to methylate, right? That's obviously less, right? That's a deficit. But what if in your daily life, you only require about 40% of your total methylation ability to get through the day and do fine? Well, you've still got 70%, you only need 40. There's no deficit that you would notice. But let's say you take a medication or you do some chemotherapy or you get exposed to certain toxins. All of a sudden, you need 80% of your ability to methylate when you've only got 70%. Now you're deficient in your ability to methylate, and we'll start seeing changes on a test like the homocysteine test. The homocysteine test, I would describe it as the functional test for your MTHFR functionality, right? Is your problem bad enough that you can't methylate enough and you're building up homocysteine, right? This is the test that tells you if that mutation has a functional problem attached to it, or if it's just a mutation and it's not bothering you at all, okay? So this is a functional test for the MTHFR mutation. It is not the genetic test. All right, I don't particularly like the idea of treating people for methylation issues simply because of a genetic mutation. I would rather say, okay, if you have that genetic mutation, that's a reason for us to keep an eye on your homocysteine level, and let's see if we need to support you or not. If we don't need to, then you don't, right? Okay, so MTHFR is associated with this. If you've heard of MTHFR mutations or if you know you have them in the family or whatever, this would be an extra important test for you. All right. Now, what do we do about it when it's elevated, right? Obviously, we can't go in and fix the genes. It doesn't work that way. But what we would do is provide two main support mechanisms. Number one, we would provide what are called methyl donors. These are nutrients or components, ingredients in supplements that can readily give up a methyl group, that carbon and 3 hydrogens. So you would take something like, for example, trimethylglycine or TMG. You could take TMG and it could go into your body and very easily throw off a couple of methyl groups that you could then use to go methylate. So if your issue with methylation is you just don't have methyl donors easily available, and therefore you're pretty sluggish in your ability to methylate, your homocysteine could go high. That could be a problem. So taking methyl donors could speed up that process because now you've got methyl groups readily available. That's one approach. The other would be to provide B vitamins, B12, B6, and folate specifically, that are already methylated, right? For example, with B12, instead of taking cyanocobalamin or hydroxycobalamin, you can take methylcobalamin, meaning it's already got a methyl group on it. That way, if you're not very good at putting the methyl group on, It's already there. You don't have to worry about it. That B vitamin comes in ready to use, no processing necessary, right? So those are the two things we do. And there are products that have those combined. There are plenty of them out there. But that's the approach, is you support either the methylation of the B vitamins or you support by giving them methylated B vitamins. Is there a chance you are just deficient in, for example, B12, but your ability to methylate is fine, you just don't have any B12 to use? Yes, could easily be the case. And that's partly why I don't normally address an issue like this by just giving methyl donors. I would give a combination of B vitamins and methyl donors so that we're handling both issues, right? All right, so that's the way we go about it. If you want a homocysteine test, if you feel like, hey, I know I've got the MTHFR issue, I want to keep up with whether or not it's bothering me, right? Whether or not it's a functional issue, then ask for a homocysteine test. Simple blood test, any doctor can do it, any doctor's office can do it. LabCorp, Quest, CPL, they all have a homocysteine test. But you're welcome to call our office and we can set you up with a homocysteine test if you like. And now you have a video that explains to you what it means and what you would do about it. But if you're someone who has that interest, or if you have a family member that has an interest in that, send the video over to them, get them educated, whatever. But feel free to contact the office. We can set you up with that, or just ask your doctor for it. And you may have to pay out of pocket. Just ask them ahead of time what it'll cost. So anyway, that's homocysteine, kind of all wrapped up into one video. I guess I didn't go too terribly long on that, like 15 minutes, but that's a good primer for you on homocysteine. It does interact with a few other tests in your body. If you do a full panel through us, we go through all those interactions, but on its own, you have a pretty good idea of what's going on now. So call us if you need one or email us. We'll be happy to get you taken care of. Otherwise, I'll see you on the next video.